Alright, this is my WebP encoding tool. I built it when I was building a 3D website and I wanted to optimize its performance and load time. So I compressed a bunch of images that were being used as textures. And there's a lot of different compression methods. There's lots of different image formats, but what I finally settled on was WebP. But what I found is if you go online to try to convert these, like PNGs to WebP, come across these tools, and I'll get into why they're really limited and why I don't use them, and why I ended up building this desktop application. But this is how it works. So we've got some test images here that we're going to feed through it. These are used as a cube map, if you know what those are. Cool. But you can see these are some pretty heavy files. That's like 2 megabytes per file. So let's select these files. We can do it one of two ways. We can either browse, like open up a dialog here, or we can just select and drag them in, drop them. And so now we've got them queued up, ready to go. We can set whatever options we want, any presets, depending on the nature of the images. We're just going to go ahead and leave most of the defaults, I think, and the output will be right alongside the originals. So let's just go ahead and encode them. I'll bring this over so you can see it happen. So we're just going to get going, and you can see the files being made, and boom, we're done. And you can tell here now, custom up, you almost cut that in half. All right, now that you've seen how it works, I'm going to show you how it works. So if you've ever built an Electron application, you can probably fast forward through this, but I'm going to kind of explain the architecture of an Electron application. So there's two processes that run, or two execution contexts that run. One is the main context, the main execution process, and this is kind of like a Node.js application. It has access to your file system. It has access to a lot of those Node.js APIs that you can use to interact with the computer or whatever system is underneath. And then that context here, the main context, is separate from the rendering context. The rendering context is like your web interface context. You don't have access to all of the very privileged APIs that you do with Node.js running like a regular application. And that's for a lot of reasons, mostly security. Because of that, you have to set up a little something known as like an inter-process communication. And if you've ever used remote procedure calls, it's a lot similar to that. Anyways, so that's how the actual Electron application kind of talks to itself between its two contexts. But how does it do any of the encoding? Well, the cool thing about Electron or desktop apps in general, you can ship static assets like images and fonts and whatnot. And you can also ship binary executables or whatever executable you want, technically. Um, you just gotta make sure that it's able to run on whatever platform the user is running on. So if we take a look at the main util, there should be, yeah, here it is. This is the simple function that just determines which platform it's on and determines which binary executable to run. And so when you call that encode button, when you press the encode button, here's what happens. It basically has a list of the file paths, and for each of them, it generates the command. It generates that cwebp command, this one right here, for every single one. It takes in options and then it appends those arguments to the command, and then it spawns child processes for each file. There's no network requests. There's no malicious manipulation of the file system or anything. It's just a simple Electron application, and you know what? They're actually pretty cool. I'm not sure if the next desktop app I'm going to build will use Electron, but it's kind of like React Native, it's neat. It's a neat convoluted hack. So, hats off to the Electron developers. Anyways, catch you in the next one.